All right, so approximating values of trig ratios. So you can determine the approximate values for sine, cosine, and tangent using a scientific or graphing calculator. Most calculators can determine trigonometric values for angles measured in degrees or radians. You just have to make sure that you're in the correct mode. All right, so if you're not sure and you plug in cosine 60 and get 0.5 as an answer, right, you are in degrees because the cosine ratio for a 60-degree angle is 1/2. Right, 1 is adjacent to the 60-degree angle, and 2 is the hypotenuse, 1/2. But if instead you get negative 0.952412, well, then you are in radians. Right, so that can just if you're not sure. All right, so we're only going to be using calculators if we have a value that is not part of a special right triangle. All right, then we're going to have to use the calculator to help us out. All right, so here we have the first one, and that is cosine negative 200 degrees. Now, it is helpful. So if it's less than 90 degrees, the answer is going to be positive, so we don't have to worry about sine. But if it's more than 90 degrees, sometimes it's going to be positive and sometimes it's going to be negative. Right? So by graphing, we can make sure we have the right sign for our particular trig function. So negative 200 degrees would be over here. All right. And so if we wanted to consider it as a positive angle, right, so negative 200 plus 360 gives us positive 160 degrees. Of course, that would then put us going this direction, right? And it does put us in the second quadrant where x is negative and y is positive. And the hypotenuse, of course, is always positive. Cosine, remember, uses the adjacent, which is x, over the hypotenuse. And so since x is negative, we would expect an answer that is less than 0. Right? And so by getting a negative answer from our calculator, we expect that. That would be correct. If we got a positive answer, that would be wrong, and we know we need to put a negative on it. All right, so we're going to try these ones. We'll graph it to make sure we know which quadrant it's in, and then we'll use the calculator, which I am going to try. I wish I could pause. I'm going to try and grab the calculator on my computer, and I think you can see that. I think you can see everything on the computer. So, applications. For some reason it goes by so quickly. And calculator, there it is. Okay, let's move this out of the way. So the calculator is going to keep disappearing, so we'll just move the screen to find him. All right, so 7 pi fits. All right, so I'm going to write these in terms of fifths, right? So pi halves, well, that doesn't work out really nicely as fifth. All right, I'll just fill in. Never mind. Maybe I'll do it for this one. All right, so pi halves, that doesn't work very nicely as a fifth. But this one would. All right, so this is pi, and so pi would be the same as 5 pi fifths. On. There we go. And this is 3 pi halves and 2 pi. And of course 2 pi would be 10 pi fifths. All right, so now which quadrant are we in? All right, so 5 pi fifths takes me here, and then I need 2 more fifths. All right, so each one of the quadrants is a half. It's pi halves, right? So is 2 fifths greater than or less than a half, right? Well, 2.5, right, would be half of 5. So it is less than a half. So it is in this quadrant. There we go. So I have a tendency to draw a triangle. We're not going to find a reference angle. Just habit, want to make it a triangle. Our reference angle wouldn't be very helpful. So this is 7 pi fifths. We are in the third quadrant where x is negative and y is negative. All right, so now we got to think about this. So tangent, I don't know if I did two. I guess I did 2 problems on each one here. Well, ignore the 260 part. Let's see if we have enough space. And if I have enough space, I'll do 2 problems. All right, so tangent, remember, is the opposite over the adjacent, or if we're looking at the coordinate plane, y over x. All right, so both of those are negative, so we're going to expect a positive answer. So now we're going to use the calculator to evaluate 7 pi fifths, and we are expecting a positive answer. And calculator, oops, we got something we don't need. Go away. Where are you? There you are, calculator. I see you. OK. All right, I am in degrees. It is easy to change this to radians. So I just need to switch to radians. Where is my, oh, no, wait, that's not going to help me. Thought I remembered. Oh, there it is. It's not in the same spot as on my phone. All right, there it is. OK, it's right there where pi is, and so I was expecting it to be there, and I'm like, oh, that's not it. All right, so now we're in radians, so that's good. All right, so we had 7 pi fifths. All right, so 7 times pi, this is not the most efficient, equals, and then divided by 5 gives us. All right, so this is a backwards calculator. So if you're using a normal calculator, you would just type in tangent and then in parentheses 7 times pi times divided by 5. Here I'm going to have to do it this way, and then I'll hit tangent. So we got as a ratio 3.0, let's round to 4 decimal places, 3.078. And it's positive, which is good, because that's what we should get. So 3.078. There we go. I think I have enough room for the next one. And since I have it already, the words already here, let's just try and squeeze that one in. So B there is cosine 260. All right, so nice and easy to work with, degrees. All right, of course, 260 is right here, also in the third quadrant. All right, x is negative, y is negative. We're looking for cosine. All right, so cosine, of course, uses only the adjacent. So we are expecting a negative answer, right? So cosine is going to be adjacent, oops, which is over the hypotenuse. So that is x over, and then hypotenuse is this rotating arm there. That's always positive. So we are going to get, we have a negative divided by a positive. That's going to be a negative answer. And let's see what we get for cosine 260. All right, now I got to switch back to degrees. Well, now at least I reminded myself where it was located. So clear. Now we're in degrees. All right, so 260, and then cosine. All right, we got a negative answer. Good. So we have negative 0.1736. Come on. Oh. All right, so that seems to be a good answer. If we had wanted, just kind of a reference here, cosine 270, would have been 0, right? Because it would have been 0 over 1, which is 0. So interestingly, we're pretty close to 0. That seems to bode well for our answer there, except we're negative. Right, so now we are looking at 4.2. That is radians. Oops, no. Let me switch colors. I have to use all the colors. All right, so 0, pi halves, pi, 3 pi halves, and then 2 pi. Well, 4.2 is definitely more than pi, right? Because that's 3.14. Approximate. Of course, 2 pi would be 6.28. All right, so now which quadrant does it lie in? Is it in the third quadrant or is it in the fourth quadrant? If you aren't sure, no problems. Just use your calculator and say, okay, what would, so 3 halves is 1.5. 1.5 times pi equal, all right, that's 4.7. All right, so, or you could just figure out what's halfway between 3.14 and 6.28. So this was 4.7, 7 I think. So it's going to definitely be in the third quadrant. All right, so that's 4.2. We are expecting a negative answer because both x and y are negative, and sine is y over r, which is always positive. So that means that sine 4.2, now we got to switch back to radians. Where are you? So I'm not a professional on the recording here, so it's just me. All right, so, oops, sorry. I forgot to switch radians. All right, now 4.2 sine, we get a negative answer. So negative 0.8716. Negative 0.8716. And of course, if we had gone all the way, well, not that far, from 3 pi halves, right, that would have been a negative 1, right, because this point here is 0, negative 1. So that seems like a good answer. And it is. And so let's look at the last one, cosecant negative 70. All right, so we can always get our coterminal angle. So negative 70 plus 360 gives us 290 degrees. What is this about? Oh, no, we're in the fourth quadrant. We're in the fourth quadrant now. Good, we're not in the third quadrant anymore. So fourth quadrant, there we go. So this would be positive 290. It is exactly the same as negative 70, except for the direction. We start and end in the exact same spot. All right, so fourth quadrant is x is positive, y is negative. Cosecant is the hypotenuse, r, over the opposite side. It is the reciprocal for, oops, well, I'm telling you it's going to be negative. It is the reciprocal of sine, and I really should have an angle there, because you can't take the cosecant of nothing. I think on one of them I forgot to put the angle in there. But no, there should be an angle in there. So since y is negative, we are expecting an answer that is negative. So cosecant negative 70 equals, and now if we look at our calculator, notice there are no buttons for cosecant, and there's no buttons for secant, and there's no buttons for cotangent. But it is okay, because we can use the reciprocal relationship. So remember that, I have it right here. Remember that cosecant is the same as 1 over sine. All right, so we will just use that fact. All right, so cosecant negative 70 is going to be the same as 1 over sine negative 70, and we'll just plug that into the calculator, which is always interestingly when you work with a backwards calculator. So if you're looking for secant and you're using a calculator, you're going to do 1 over cosine. If you're looking for cotangent and you're using a calculator, you're going to do 1 over tangent. All right? So that's how you'll get those three, because they're not on the calculator. All right, so let's try to do this. Oh, we graphed it, and we're expecting a negative answer. And I'm hoping that I can get this into the calculator, because it's really very picky. All right, so I'm going to have to use parentheses. 1 divided by, because I've got to hit the angle first. And actually, I've got to hit this and then make it negative. See, very fussy. And then hit the sine. Oh, except we're in degrees, which means, forget that, change to degrees first. Now, 1 divided by parentheses so that I can hit the 70 negative. Right. If I don't do the parentheses, it'll do 1 divided by 70 and take the sine of that. Instead of taking the sine of 70, a negative 70, and putting that under 1. So dividing 1 by that value. So sine, there we go. And it's a negative, which is what we're expecting. And close the parentheses and hit equals. And there we go. There is our value for cosecant, negative 1.0642. Negative 1.0, was it 642? 642, okay. All right, and so you just have to be a little creative if what you're looking for is cosecant, secant, and cotangent. Always double check to make sure you've got the right sign by graphing your angle and seeing what sign you are expecting. All right, so that's it, I think, for this video. Oh, one last little thing. And then that's it for this video, because it's time for you to do some problems. Oops, we didn't go the right direction. So just some little hints on possible values. All right, so sine and cosine cannot be larger than 1, nor smaller than negative 1, because the hypotenuse is the largest side in the triangle. So if you divide something smaller by something larger, you're going to have something that is less than 1, or greater than negative 1, right, depending on whether you're positive or negative. So sine and cosine values are always sandwiched in between negative 1 and 1. On the contrary, secant and cosecant have the hypotenuse in the numerator, right? So the hypotenuse is the larger side. If you're dividing something larger by something smaller, right, you're going to have something greater than 1. So secant and cosecant are either going to be smaller than negative 1 if they're negative, or greater than 1 if they're positive. Right? So in other words, their absolute value is greater than 1, whereas sine and cosine absolute value is less than 1. And tangent and cotangent can be anything, because they use sides, and the sides can be anything. So they can be small or large, depending on what the sides are. All right, thanks for watching. Bye for now.